Hello friends, today we are discussing the part 7 of this lecture series, that is input output exceptions and interrupts, which is related with the unit 6 exceptions and conditions. The exception condition, the interrupt 0, which is a divide error. The divide error fault occur during the division or an I division instruction when the divisor is a 0. At that time, the interrupt 0 error is occur. Okay. So interrupt 1, that is a debug exception. The processor or a trigger this interrupts. The processor trigger these interrupts for any of the number of the conditions. An exception handler can examine the debug registers to determine which condition caused the exceptions. A divide error, which is also a interrupt 0, is occur. A divide error is occur when during a division or a I division instruction when a divisor is 0. At that time, the exception or a interrupt 0 is echo. When a processor triggers these interrupts for any of a number of the conditions, the debug exception, that is an interrupt 1, is echo. The exception handler can examine the debug register to determine which condition caused the exceptions. This is interrupt 2 is a hardware interrupt assigned a permanent vector. This is an hardware interrupt assigned to the permanent vector, that is an interrupt 2, which is a NMI, that is a non-maskable interrupt. Interrupt 3, that is a breakpoint. The INT3 instruction calls this trap. A debugger typically uses the breakpoints as a way of displaying the register's variable etc at a crucial point in a task. Interrupt 3 is cause it is a breakpoint. Interrupt 3, it is an instruction breakpoint. A debugger uses the breakpoints as a way of the displaying the register's variable etc at a crucial point in a task. Interrupt flow, which is an overflow. This trap occurs when a processor encounters an INT 0 instruction and the overflow flag is set. When doing the arithmetic on sign operands, careful parameters, programmers and compilers either test OF directly or use the INT 0 instructions. This step occurs when the programmer or a processor encounters an INT 0 instruction and overflow flag is set. So interrupt 4 is an overflow flag. So whenever the overflow is occur, at that time the interrupt 4 is evoked. When doing the arithmetic on sign operands, careful parameters and the compilers either test the overflow flag directly or use the INT 0 instructions. Interrupt file bounds check. This fault occurs when a processor, while executing a bound instruction, finds that the operand exceeds the specified limits. The interrupt 6, that is an invalid opcode. This fault occurs when an invalid opcode is detected by the execution point. No error code is pushed on a stack. The exception can be handled within the same task. This fault occurs when an invalid code is detected by the execution unit. The fault occurs when a processor, while executing the bound instructions, find that the operand exceeds the specified limit, that is an interrupt 5. The interrupts is this exception also occur when the type of the operand is invalid for a given operand. No error code is pushed on a stack during the interrupt 6. The exception can be handled within the same task. Interrupt 7, that is a coprocessor not available. Whenever there is no coprocessor available, so at that time the interrupt 7 is evoked. The processor encounters an ESC escape instruction and EM emulate bit of a CR0, that is a control register 0, is set. When a escape bit and a EM bit of a CR0 register, that is the control registers, are set, at that time the coprocessor come to know that there is a no coprocessor is available. The processor come to know that their coprocessor is not available, and the interrupt 7 is evoked. The processor encountered with the wait instructions or an escape instructions, or and both the MP and a TS bits of the CR0 are set. There are two conditions when the interrupt 7 is evoked: when the escape and EM bits of the CR0 is set. At that time, the processor come to know that a coprocessor is unavailable, so the interrupt 7 is evoked. So when another condition is that when a processor encounter either the wait instructions or escape instructions, and both the MP and a TS bit, that is a monitoring the coprocessor and the task switch bits of the CR0 as a set. At that condition, the processor come to know that the coprocessor is unavailable and a interrupt 7 is evoked. So interrupt 8, that is a double fault. When a processor detects an exception while trying to evoke the handler for a prior exception, processor cannot handle them serially. It signals the double fault exception instead. The error code is always 0. When a processor detects an exception while trying to evoke the handler for a prior exceptions, the processor cannot handle them serially. It signals the double fault exception instead. The error code always 0. The faulting instruction may not be restarted if any other exception occurred while attempting to evoke a double fault handler. The processor shutdowns. The interrupt sig, that is a processor segment overrun, which is when equivalent to a general protection fault. It will trying to load or store the floating point number beyond the limit of the data segment. Whenever while trying to load or store a floating point number beyond the limit of the data store, that is at that time the coprocessor segments are overrun and the interrupt 6 is evoked. The interrupt 10, that is the invalid TSS task switch segment, that is occur if during the task switch a new TSS is invalid. Interrupt 6, interrupt 10 is evoked when during the task switch a new TSS is invalid. Another condition is that an error code is pushed onto the stack to help identify the cause of the fault. Interrupt 11, segment not present. While attempting to load the code segment, data segment, extra segment, FS or a GS register, loading the SS register, however, causes a stack fault. While attempting loading the LDT register with a LLDT instruction, loading the LDT register during a task switch operation, however, causes an invalid TSS exception. While attempting to use a get descriptor that is marked not present, this fault is restartable if an exception handler makes the segment present and returns. The interrupted program will resume executions. While attempting loading the LDT register with an LLDT instructions, loading the LDT register during the task switch operations, however, causes the invalid TSS exceptions. While attempting to use a get descriptor that is marked not present, this fault is restartable if the exception handler makes a segment present and return. The interrupted program will resume the exceptions. Interrupt 12, a stack exception as a result of a limit violation in any operation that refers at the stack segment registers. When attempting to load the stack segment register with a descriptor that is marked not present but is otherwise valid. Interrupt 13, general protection exception. The protection violation that does not cause another exception causes a general protection exception. The general protection exception is a fault. Interrupt 14, that is a page fault. This exception occurs when a paging is enabled. A page directory or a page table entry needed to be addressed translation has 0 in its present bit. The current procedure does not have sufficient privilege to access the indicated pages. As a result of the limit violation in any operation that refers to the SS segment, the interrupt well is echo. When attempted to load the stack segment register with a descriptor that is marked not present, but it is otherwise valid, at that time the interrupt well is echo. All protection violation that does not cause the another exception causes a general protection exception. At that time, the interrupt 13 is occur. The page directory or a page table entry needed for the address translation has a 0 in its present time. At that time, the interrupt 14 is echo, which is a page fault. Page fault error code format. As shown in a figure, a description is there. The access causing the fault originated when a processor was executing in a supervisor mode. At that time, the US bits are set as a 0. When the US bit is set as a 1, the access causing the fault oriented when a processor was executing in a user mode. Read or write bit when the value is 0, the access causing the fault was read. When a value is 1, the access causing the fault was write. When a p bit value is 0, the fault was caused by the non-present pages. And a p bit value is 1, the fault was caused by the page level protection violation. Interrupt 15, which is reserved, and the interrupt 16, which is a coprocessor error. The 80386 reports this exception when it detects a signal from 80287 or a 387 on a 386 error pin. The 386 tests this pin only at the beginning of a certain escape instruction and when it encounters a wait instruction while the EM bit of the MSW is 0. Thank you friends for watching the video.